Welcome in this new session. In this session, we'll discuss one of the most important water parameters, which is called TDS, Total Dissolved Solids. It's important for you in desalination plant, drinking water, cooling system, boiler, wastewater, and any system has water. It's very important. It's important like pH, conductivity, and others. So let's discuss it together and dive in this topic. TDS simply stands for total dissolved solids, which is the measurement of the total concentration of dissolved solids in water. So keep in mind it's dissolved solids, okay, because there is another term close to this one. Now these dissolved solids could be ions, inorganic ions, sometimes organic ions as well. So, but mainly the most common ions exist in water are like sodium, cation, chloride, calcium, magnesium, sulfate, nitrite, phosphate, bicarbonate, and many others. Those ions, once they got dissolved in water, they will be in with a charge, whether it's a positive charge or negative charge. Now, for your information, we classify water based on their TDS according to USGS into 4 categories. Maybe these categories are not classified the same in your country, but this is a general US classification for different type of water. If your water has a TDS value less than 1000 milligram per liter, so the unit of TDS is milligram per liter, or we call it simply ppm, parts per million. Okay, so if your water has a TDS less than 1000 milligram per liter, we can say that this is a fresh water. Fresh water could be drinking water, could be other water, but it's a fresh water. Now, if your TDS of a water has between 1000 to 10,000 milligram per liter or ppm, that means, or we classify this water as brackish water. Brackish means it has salts inside, high level of salt. But what if the TDS of your water has very high level of salts, between 10,000 to 35,000 milligram per liter? We call this type of water as saline water. So it has high level of salts. And finally, we have the fourth category of water, which is having a TDS more than 35,000 ppm or milligram per liter. We call it hypersaline. Again, this classification, it may not apply in your country. In different countries in the Middle East, in North America, South America, in India, in China, we may have different classifications, but this classification is as per the USGS, okay? So maybe in other countries we have up and down, but as per the WHO, which is World Health Organization, a water with TDS less than 500 milligram per liter, we call that water as drinking water. If you want to get the details of WHO standards for drinking water, you can find it in the resources and you can get the material over there. So I'll give you different standards of drinking water. One of them is WHO, which stands for World Health Organization. So this is the basic definition of water. So simply, if you have a water and inside we dissolve some salts, once the salts get dissolved and disappeared, the TDS of that water will increase. So this is simply the meaning of TDS, total dissolved solids. This is a very important topic to discuss it together. When we measure the TDS, there is an international procedure to measure it. The approved one as per the standard methods for water and wastewater is through evaporation. So we get 1 liter of water, we evaporate that water, and we have the remaining salts. We measure the amount of salts, we weigh that amount of salts, and we represent it as milligram of salts per 1 liter sample. But we cannot do that from day-to-day activity because such evaporation could take 1 hour, could take more than that or less than that. And after that, we need to dry the tools and so and weigh in an accurate way the remaining salts. So simply, we have something called conductivity conversion method. If you remember in previous sessions when we discussed the conductivity, we said when conductivity increases, TDS increases. And on the other side, when conductivity decreases, TDS decreases as well. So they are going in parallel, either up together or down together. Now, there is one of the basic methods to measure TDS is by a conductivity conversion. So we measure the conductivity through a conductivity meter, as we have seen there, using any 1-hack, Myron, or any other tool. Then we have a factor, we multiply that conductivity with a factor, then we can get the TDS. Okay, this factor is ranging between 0.5 to 1. This is in average. Sometimes it could be lower than 0.5 in some cases. Okay, so this is the factor. That means always, rule of thumb, always TDS is lower than conductivity, okay? Because the maximum factor will be 1. So, but most of the cases will be less than 1, between 0.45, for example, up to 0.95. So, always conductivity is higher than TDS. No way to have a TDS higher than conductivity. Keep that fact in mind if you are using conductivity meter. Now, but the problem, when we measure conductivity, we have 3 options to measure it. The first option we call it KCl, the second option we call it NaCl, and the third option we call it 442. In some instruments we call it natural water. It depends on your model and the brand you are using. So the problem here, when you measure the conductivity, you have to select one of 3 options there. The first option of measurement as KCl, the second NaCl, the third is natural water or 442. But the question, which one I have to use? Number 1. Number 2, which factor I have to use is number 2. Number 3, there are some specialists could assume that whenever you have a conductivity, multiply that conductivity by 0.7 or 0.67 or 0.65, depends, you will get the TDS. Is it rule of thumb correct? Is it applicable everywhere? The answer, not. We cannot rely on a factor always applied in all type of water. So if you get a drinking water, similar if you get salt water, if you get seawater, we can multiply it by 0.65 and get the TDS. This is inaccurate because the factor is ranging widely between 0.45 up to 1 in some cases. Okay, so which measurement option we have to use? Is it KCl, NaCl, or 442? Simply that depends on the application. Now, for most of the calibration activities or scientific researches, we use the option of KCl. What's that option means? That option means we assume all the salts inside your water sample, or we assume, it's not correct, we assume all the salts of your water sample are represented by potassium cation and chloride anion. So we calculate the conductivity coefficient based on those 2 ions. Okay, so this is applied mainly in research, chemistry researches, or applied for calibration of the instruments, or maybe other limited lab applications. Okay, the second measurement option is called NaCl. What's the meaning of that? We assume all the ions inside your water sample are sodium cation Na+, and chloride anion, which is Cl-. It's an assumption again, in order to calculate the conductivity coefficients and other. When we can use this option to measure NaCl, for example, when we measure seawater conductivity, we can select NaCl because the level and the concentration of chloride and sodium in seawater is very high. The second, if we have different brine or hypersaline or saline solutions, also we can use this option. And lastly, we can use it for some researchers or lab activities as well. We can use the measurement option of NaCl. But there is a third measurement option, you can find it in some instrument. It's called natural water or 442. That means we assume that this water has three different compounds. The first one, 40% of these ions are represented by sodium sulfate. Another 40% is represented by sodium bicarbonate, NaHCO3, and 20% of the salts existed in this water as sodium chloride, NaCl. So it's a bit different and wider range of ions and cations. Mainly sodium is the cation, but different types of anions. So this type of measurement as 442 or natural water, we use it for natural water. If you have a lake or if you have industrial water, any source of natural water, whether fresh water, drinking water, wastewater, we can use this option. We can use this option for different water treatment systems or different water systems as well, for desalination activities, for cooling systems, for boilers. For a wide range of systems, we select to have this wider range of ions inside your water as 442. Finally, if you are going just to the environment and you have lake water, well water, or you have some different streams of water, you can use this type of measurement as 442. Keep in mind, I may analyze the TDS or conductivity, and you may analyze the same sample TDS and conductivity. We may have different results. Why? Number one, that could be related to different temperature during the measurement, or that could be related to different measurement options. Maybe you have the measurement as per KCl option, or I did the measurement through NaCl, or somebody else did the measurement through 442. So we have to be careful about the most appropriate selection of your conductivity or TDS measurement. This is a very important example about why we cannot specify an exact conversion factor. It's not correct if you find sometimes that, okay, as a rule of thumb, you can multiply the conductivity by 0.65. It's not correct. Or as a rule of thumb, you can multiply the conductivity by 0.7 to get the TDS. It's incorrect because that depends on many factors. Let's see those examples. For example, for different types of water, from conductivity 84 microsieverts per centimeter up to 15,000 microsieverts per centimeter, we can notice one thing, that if we did the measurement through the KCl option of the water sample of 84 microsieverts per centimeter, we can see that the value of TDS is only 40.3 ppm or milligram per liter, and the factor is 0.5. But for a moderate sample like brackish water of a TDS 1500 or of a conductivity 1500 microsieverts per centimeter, the TDS is 757 ppm. That means the factor is 0.5047, so it's a bit different than the previous one. But if we have hypersaline water sample with a conductivity of 15,000 microsieverts per centimeter, we can see the TDS is 8,700, so the conversion factor is 0.58. So we can notice here that if you have a selection of KCl, the conversion factors will be widely different between 0.5 up to 0.58. Okay, so there is no fixed conversion factor, but that depends on each type of your water sample. Number one. Number two, let's compare between the TDS for the same sample using three options. For example, we have a water sample here of 84 microsieverts per centimeter. If we did the measurement of TDS through KCl, we will get only 40 ppm. But if we did the measurement through the option of NaCl, we will get a TDS value of 38.04 ppm. So it's lower than the case of KCl. But if we did the measurement through the option of 442, we can notice that the TDS will be higher. It will be 50 ppm or milligram per liter. So and just look at the conversion factors. Here in the case of KCl, it's only 0.5048, but in the case of NaCl, it's lower than that, 0.4755. But in the case of 442, it's higher, 0.6563. So you can see for the same sample, if we change the measurement option all salts representation, we can have 3 different values of TDS. Now let's look at a brackish water sample of a conductivity 1500 microsiemens per centimeter. If we did the measurement of TDS through KCl, it's going to be 757 ppm. If we did it through NaCl option, it's going to be 737. But if we did it through the option of 442, we can get it as 1050 ppm. And you see the conversion factor here 0.5, here 0.49, and here 0.7. You see, if you measure the same sample there, using KCl option, you'll say that, okay, my TDS is 757 ppm. But if I did the measurement through the option of 442, I'm gonna get 1050. Okay, so there's a big difference when you change the measurement option. Let's see the last sample here. If we have a brackish or saline water sample of a conductivity 15,000 microsiemens per centimeter. If we measure TDS through KCl option, it's going to be 8,700 something. But if we did it through NaCl, it's going to be 8,500 something. But if we measure the TDS through the option of 442, it's going to be 13,400 something. So you see, there's a huge difference. What if I want to do a design for a desalination plant, or a design for a cooling tower, COC, cycle of concentration, or I want to do a design for wastewater, or I want to design a drinking water facilities? We have to unify the measurement options. Otherwise, we may get different results for the same water sample depending on your measurement option. You see here in the last sample, hypersaline sample of the same conductivity, we can get 3 different TDS, and just look at the factors here. In the case of KCl, it's going to be 0.58. In the case of NaCl, it's going to be 0.56. And in the case of 442, it's going to be 0.897. There is a big difference in the conversion factors. That's why we cannot say that we have a fixed conversion factor from conductivity to TDS applied in all water types. No, that depends, number one, on how much the conductivity of your original sample. Is it low range or high range? Is it just few ppm or few hundreds or few thousand? Number two, that depends on the measurement options you have it in your case. Are you measuring that through KCl, NaCl, 442, or what we call it natural water? Be careful when you measure a conductivity and TDS always, whether you are in the field or online or do that in the lab. So we have internationally 2 methods could be used to measure the TDS. The first one, which is the only approved one, which is, we call it evaporation method. If we got 1 liter of your water sample, we need to evaporate that water sample and measure the remaining salts by weight. So we calculate how much milligram of salts kept remaining in your 1 liter sample, as for example few hundred or 50 milligram per liter or 1000 milligram per liter. This is the only approved method internationally according to standard methods for water and wastewater handbook. But for our daily activity, we can rely on the method called conductivity conversion. It's not internationally applicable always and approved always. There are some standards and some companies doesn't approve that to design a plant based on that, but it's applied on our daily activity. It's applied for your daily testing. It's applied for doing a services or online testing for different water systems or water bodies as well, which is a fast test. It just takes a few seconds to do that test. Okay, so here we can see that there are different levels of TDS and different rating of water, whether it's suitable for drinking or what, but that also depends and could be changing from country to country. From my experience, and during my 15 to 16 years experience in the field of water treatment, I like to use the Myron 6P instrument, portable meter. It's fantastic. I'm not doing marketing for that instrument, but it's really good instrument to have it. Handy instrument. You can take it anywhere and it's reliable. You can just do the test very fast with accurate results, or you can use different hack instruments as well. Hack is one of the leading international companies to supply you with all instrumentations as well as reagents could be used in your water testing and water measurements. This is an example of how water TDS could be changed from all over the world. You can see that in some red areas here we have high level of salts, but in other parts of green or blue parts it has low salinity level. For example, here the blue part has 32,000 ppm of salts and 38,000 represent the red, dark red color. And you can see here, for example, in these Arab countries close to Saudi Arabia, close to Emirates, Qatar, Oman, and those countries, we have red color. That means we have very high TDS, because this area in the world, even in the North Africa side, we have many desalination plants over there. That means we have a brine water is going back to the sea, and as well as most of the seas here are a bit restricted, so there is no much flow of water there, so that salt level will be a bit increasing with evaporation. Okay, and in many other parts of the world, especially in the northern side of the world, you will find the TDS is low because we have icebergs, we have ice, which has low level of salts. So you can find the TDS over there, 33,000 ppm in the northern and southern parts of the world. This is simply an example of how TDS will be distributed all over the world, from country to country and from area to area. I hope you enjoyed this part, and I think it's worthy to get a break right now, and we can come back once you get your coffee or get your break, and see you in the coming sessions. I hope you understood the meaning of TDS and you understood different type of measurements between of conductivity and TDS, such as KCl 442 and NaCl. And I hope now you have an idea, general idea about the conversion from conductivity to TDS, that there is no rule of thumb, there is no an exact figure. You can just multiply that one and you can get your TDS. This is a very important topic. You have it in your drinking water quality. If you look at any drinking water, you will find a TDS, total dissolved solids, there in milligram per liter or ppm. You can find it in your wastewater. If you have a sample there, you can find it in drinking water, in cooling systems, in boilers, in jackets, cooling, in any water in the world. It's worthy to look at the TDS of that water. Hope you enjoyed this part and see you in coming sessions. Thank you.